information systems, we said they are no longer monolithic mainframe based systems, but mostly combination of networks which are distributed. So, first we will look at the centralized systems. All the components are hosted by a central multi-user system. So, all the components are running in a central computer, and these are multi-user systems. Users interact with the host computer via terminals. So, most of these terminals will be dumb terminals, or they may not have any processing capabilities in the terminals, but they interact with the host computer through the terminals. All of the actual processing and work is done on the host computer, which will be most probably a mainframe computer. So, this diagram shows the centralized systems. So, you can see the computer in the center, which will be most probably a mainframe computer system, and you have all these dumb terminals shown here, but all the processing is done here. I am doing all the processing here, and all the systems databases are also located in this single mainframe computer. So, this provides interfaces to the terminals for the multi-users to do their work. Now, in this case, what happens is, if something goes wrong with this mainframe computer, none of the terminals will be able to do any work, because they cannot do any processing, or they do not have access to any data if something goes wrong with the mainframe computer. Now, this system is sort of outdated now. What we have mostly are the distributed systems, where the components are distributed across multiple locations and computer networks. Processing workload required to support these components are distributed across multiple computers on the network. It is not a single computer that does the processing work. That entire load is distributed among multiple computers on the network. This is more complicated and more difficult to implement than centralized systems, but of course, there are advantages. Now, we will look at why do we use these distributed systems. Because one thing, this is the way that modern businesses are already working, because if you take a bank, for instance, banks are distributed. If you take a single bank like HSBC or something, you will find their branches distributed all over the world. Similarly, if you take a supermarket chain or a hotel chain, like if you take the Hilton or something, you will find that those hotels are located all over the globe. So, therefore, their businesses are spread globally, and distributed computing moves information and services closer to the customers and consolidates the incredible power of the computers of today. More user friendly as they use the PCs as the user interface processor, because a personal computer is more user friendly than a dumb terminal. PCs and network servers are much less expensive than mainframe computers. So, there is a big trend today towards distributed systems using not mainframe computers, but personal computers with very high power. The disadvantages are of distributed systems. Network data traffic can cause congestion that actually slows performance. So, that is because the data has to be taken from one place to another, and if the network is congested, the flow of data will not, or the processing that is required will be slow. Higher security risks due to more possible access points for intruders and possible communication with insecure systems. So, you have to build very secure systems, because they are available at different points, and therefore, more intruders also can break into these systems. Many centralized legacy systems are gradually being transformed into distributed information systems. Now, in these distributed systems, you will find many architecture layers. That is what you mean by different layers. All the work is not done at one layer. Maybe you will have different layers performing different functions. So, there are layers like the presentation layer, presentation logic layer, application logic layer, data manipulation layer and data layer and so on. So, we will look at each one of these layers, what is the presentation layer doing. This is the actual user interface which presents inputs and outputs to the user. So, this is the layer actually that will be dealing with the actual user. So, this is the contents of this layer only will be seen by the actual users. Then the presentation logic layer, any processing that must be done to generate the presentation, that is the way the users see the input or way the output is formatted, the logic for that will be contained in the presentation logic layer. Then the application logic layer, all the logic and processing required to support the actual business application and rules. Example, credit checking, calculations, data analysis. So, all these things, actually the actual programming concerned with the business processes are located in the application logic layer. Then the data manipulation layer, commands and logic required to store and retrieve data to and from the databases. So, whenever users require some data from the system or you want to put some data into the system, this is the layer that deals with that kind of work, manipulates the data. That is, it contains the commands and the logic means the programming required to store and retrieve data to and from the databases. Then the data layer, the actual stored data in a database. So, data layer is concerned with the actual storage of data in the database, actual physical layer. So, there are three types of distributed systems architectures. We said nowadays mostly systems are distributed. This can be implemented in three ways. You can have a file server architecture, you can have a client server architecture, or it could be an internet based architecture. So, we will look at each one of these different architectures. If you implement a distributed system using the file server architecture, that is the first type that we talked, these layers are there in all, whatever the way in which you implement, these different layers will be there. So, in a file server solution, the data layer, that is the actual storage of data, that will be stored on the file server. So, the data will be actually stored on the file server. Then the data manipulation layer, that is the code that is needed or the programs that are needed to access the data from the database, to or from the database. That code will be on the client, not on the server, but that will be on the client machine, that is executed on the client machine. Then the application logic layer, the actual processing of that data or the actual business process again will be executed on the client. Presentation logic layer is also executed on the client machine, and the presentation layer is also displayed on the client machine. So, if you take a file server solution, this is the way it will be done. So, file server architecture, usually it will be a local area network or a LAN based solution. LAN is a set of client computers connected over a relatively short distance to one or more servers. So, a local area network, as the word suggests, it is localized in a certain area within a short, maybe a campus or in a single office or very short distance from one machine to another. A server computer hosts only the data layer. So, as we showed in this diagram, you can see the data layer is stored on the file server. All the other layers are implemented on the client PC, practical only for small database applications shared by relatively few users. So, this kind of file server architecture is usually used in a small location with very few users. The disadvantages of this is large amount of unnecessary data must be moved between the client and the server. So, usually when the clients need the data, whole lot of data which may not be really necessary for the client also may be moved from the file server to the client. Reduce network and application performance. So, because you are sending a lot of information through the network, it may reduce the performance. the client PC must be very robust. Robust means it must be very powerful and dependable, because all these layers are on the, you can see the data manipulation layer, application logic layer, presentation logic layer and presentation layer are all executing on the client machine. So, therefore, the client PC must be a very robust machine. Database integrity can be easily compromised. Integrity means the actual dependability of the database can be compromised, because even unnecessary data may go to the clients. Then if you look at the client server solution, this is the diagram which shows a distributed system using a client server solution. So, there can be many solutions here. Again, you can see the data layer. Data layer is being, it could be a distributed presentation 2-tier, or it could be a distributed data 2-tier, or distributed data and application 2-tier solution. So, we will look at the first one, the 2-tier solution. Data layer is stored on the database server. Data manipulation layer is executed on the database server. Application logic layer is executed on the server. So, you have a database server, and the database server, the actual data will be on the database server, and the data manipulation work also is executed on the database server. Application logic layer is executed on the server, but presentation logic and the presentation layer are executed on the client. So, that is one way in which we can implement the client server solution. Then another solution is data layer is stored on the database server. Again, execution of the data, that is data manipulation layer, is also on the database server. These are executed on the client. Then again, the data layer is stored on the database server, executed on the database server, and in addition to this database server, there is an application server here. So, the application logic layer is executed on the application server, but the other two, that is the presentation logic layer and the presentation layer, are executed on the client. So, these are the various ways in which you can implement these client server solutions. Client server architecture, the presentation, presentation logic, application logic, data manipulation and data layers are distributed between the client PCs and one or more servers. So, there can be the database server, or there can be an application server. So, any combination of personal computers or workstations sometimes connected. So, you can see an example of a client server architecture in this diagram. So many users, and there are two servers here, the sales section, account section, design section, construction, they are all connected together through this system. And then the clients may be thin or flat. These are two words that I use. The clients that are in this diagram, where we call, we said sometimes the clients in here in this first one, you can see the client has only the presentation logic and the presentation layer. Here the application logic layer and the presentation logic layer and presentation layer, they are all on the client. Here there is a separate application server. There are two servers there, database server and the application server, and only these two layers, presentation logic layer and the presentation layer, are displayed on the client. So, there can be different types of clients. So, when you say client may be thin, it is a personnel that does not have to be very powerful, acts as a terminal only. It can be all the logic and everything is on the server. The client is a very thin client. It acts as a like a terminal, dumb terminal on a mainframe computer. Here, if it is flat, it could be a personal computer, notebook computer, or a workstation that is typically very powerful. Almost all PCs come under this category. Servers in this client server architecture, the server must be more powerful and capable than a server in the file server model, because it does more work. And several types of servers may be used in a client server solution. There may be a database server, a server that hosts one or more databases. There may be a transaction server, a server that hosts services which ensure that all database updates for a transaction succeed or fail as a whole. So, transaction servers are especially important in systems that are used in banks and so on, because number of transactions may occur at the same time. So, therefore, transaction server, a separate transaction server is there to see that all database updates for a transaction succeed or fail as a whole. Then there may be an application server which serves all the, it contains all the host application logic and services for an information system. Then messaging or groupware server, a server that hosts services for groupware. Then a web server, a server that hosts internet or intranet websites. Then you can have client server distributed presentation, a client server system in which presentation and presentation logic are shifted from the server to reside on the client. So, the presentation layer and the presentation logic layers will be on the client. Or it could be a client server system in which the data and data manipulation layers are placed on servers and other layers are placed on the client. So, that previous diagram showed all these things. This is also called a two-tiered client server computing. Then client server distributed data and application, client server system in which the data and data manipulation layers are placed on their own servers, application logic is placed on its own server, presentation logic and presentations are placed on the clients, also called three-tiered or n-tiered client server computing. N means any number of client servers. Then we have the final type of distributed systems we discussed, network computing solutions. So, here again you have all the layers, data layer, data manipulation layer, application logic layer, presentation layer and the presentation logic layer. So, where are all these things stored? The data layer will be stored on the database server and the data manipulation work will be executed on the same database server. Application logic layer will be on the application server. Presentation logic layer will be distributed from the web server. So, here you have another server which the presentation logic layer is distributed from the web server and the presentation layer is displayed on the client. So, client contains only the presentation layer. So, internet based architecture, this is presentation and presentation logic layers are implemented in a client side web browser. So, the web browser is in the client side and presentation and presentation logic layers will be implemented there. Presentation logic layer then connects to the application logic layer that run on an application server, which subsequently connects to the database servers. Client server and network computing made it possible to distribute data without loss of control. Control is accomplished through advances in distributed relational database technology. So, control, that is distributing data without loss of control, that is somebody has to keep the control on the data that is on the data server, but it is distributed to the clients. And the control is accomplished through advances in distributed relational database technology. So, the relational database technology has advanced so much. So, therefore, you can have control accomplished through these advances. In the distributed relational databases, data is kept in tabular form. Each file is implemented as a table in the database. Each field is a column in the table and each record is a row in the table. So, related records between two tables, that is if you take as an example customer and order, because we know these two things are related, because It is the customers that place orders and orders are placed by customers. So, this is implemented by internally duplicating columns in the two tables. So, the relationship is maintained by duplicating a column which keeps the customer number or the customer identification will be there in the customer table as well as in the order table as a column. So, most probably this column will contain the customer number which will uniquely identify each customer. Then distributes or duplicates tables to multiple database servers located in important locations. So, the same copy of the database will be kept in multiple database servers located in different locations. So, the management of this is done, management of these relational databases which are distributed in different locations will be done by this distributed relational database management systems, or what we call the RDBMSs. The software required to implement distributed relational databases. So, you need the software to manage these relational distributed databases. It controls access to and maintenance of the stored data in the relational format, provides backups, recovery and security. So, these are the various functions that are provided by the RDBMSs, also called as client server database management systems. Examples for these are Oracle, SQL Server, Sybase and so on. Supports two types of data. Data partitioning truly distributes rows and columns to specific database servers with little or no duplication between servers. So, depending on the requirements of different clients, data can be partitioned. So, partitioned into different rows and different columns. That is, when we talk about rows, if we take an example as a bank, for instance, now if we take a bank like this Bank of Ceylon or People's Bank, there are customers spread out all over the country. There may be customers coming from Mathura, Galle, Colombo and so on. So, your entire database can be partitioned. Say for Mathura customers, all the data belonging to those Mathura customers, those rows may be stored in a location close to Mathura. The Colombo records may be in a location in Colombo. So, like that the data can be either partitioned either as rows or partitioned in the form of columns, so that you have less duplication. Then the data replication duplicates some or all tables on more than one database server. Sometimes you need to replicate this data also, because customers maybe, though they are from different regions, they may do their, like say a customer coming from Mathura to Colombo, he may withdraw his money from Colombo, but his account is actually in Mathura. So, in that kind of situation, you may need to replicate the data too. So, for a given information system application, the data architecture must specify the RDBMS technology and the degree to which data will be partitioned or replicated. One way to record these decisions is to record them in a physical data store. So, how are you going to partition or how are you going to replicate? All this information again need to be stored somewhere. So, for more information on this, I would like you to refer to page 495 in the reference 1 book. Then the interface architectures. We have looked at the database architecture. Let us look at the interface architectures. Now, this depends on whether you do your processing, that is whether you consider your inputs in the form of batches or in the form of transactions. Now, batch inputs or outputs, whether you consider your processing in the form of batches, then the transactions will be accumulated into batches for periodic processing. That is, every time a transaction occurs, you are not going to do the processing. What you are going to do is, you are going to collect these transactions into a batch and then process them periodically from time to time. So, batch inputs, examples can be time cards, are processed to update databases and produce appropriate outputs, that is paychecks, generation of invoices and so on. Especially if you take the paychecks, you know, now in our country mostly the payment, that is the salaries are paid at the end of each month, but you will accumulate all these transactions, like if people have taken loans and so on, they have to be deducted. Then if people are paid on a daily basis, then their attendance has to be fed into. So, every day when you your attendance sheets and so on will be fed as a batch, not as when attendance is marked every day. So, these are examples for batch inputs. Again, you can refer to page 496 in the reference 1 book for more information. Then the online inputs or outputs is different from the batch processing, because this provides a more conversational dialogue between the user and the computer application and provide immediate feedback in response to transactions, problems and inquiries. So, the moment a transaction occurs, say for instance, the moment a customer in a bank withdraws his money, the moment that transaction is done, your record has to get updated. That is, your balance amount in the account has to be updated. The transactions are not going to be collected in this case, like a person will withdraw money or deposit money from time to time, but it is not going to be collected over a period of time, and then his account is not going to be updated. The moment he input some money into the account, the account is going to get updated, the balance amount will be updated. Similarly, when the person withdraws money, immediately his account is going to get updated. Also, if there is a problem in the system and if there is an error message that comes on the screen, immediately it will be a solution will be given. And inquiries, say supposing a person goes into a teller machine and he wants to know how much of money is available in his account. So, immediately there will be a response to this inquiry. So, this provides greater human interaction in decision. Again, you can refer to page 497 in the reference 1 for more information. Then also this batch processing can occur as a remote batch processing, combines the best aspects of batch and online inputs and outputs. Here the batch may be collected in a remote location and then it will be input as an online input and the output will be produced. This is you can take these examples from the reference book. Again, look in the page 497. Again, the interface architectures, you have to consider how the data is going to be input. For example, you can use a keyboard for input, or it could be keyless data entry without using a keyboard. How the data can be entered, like automatic identification. Keying in data has always been a major source of errors in computer inputs. So, whenever you use a keyboard for data entry, any number of errors can occur. In batch systems, keying errors can be eliminated through optical character reading (OCR) and optical mark reading (OMR) technology. So, usually in batch systems, you can use this optical character reading or optical mark reading. Like as an example, I can give you now in the BIT examinations, what we use for this OMR, you use the OMR technology for correcting the multiple choice questions. So, where people do not enter the data into a system using the keyboard, it is automatically read by the optical mark readers. The real advance in keyless data entry are coming for online systems in the form of auto identification systems, example barcoding schemes, and also these magnetic readers where you have your card, plastic card with your information coded in magnetic form. That is the type of card we use in teller machines. Or barcoding systems are used in supermarkets, where each item is barcoded, the price and all the other information about the item is given through the barcode, and the person sitting in the POS terminal or point of sale system or the cashier does not have to enter these things, this information through the keyboard. So, advantages are it processes the transaction very quickly and also errors are not made. And another type of input is a pen input. A pen based operating system become more widely available and used, example in Palm OSs and Microsoft Windows Mobile. Uses this technology to remote data collection. Again you can use refer to the pages 498 and 499 for more information. Then the electronic data interchange, or what is called the EDI. This is a standardized electronic flow of business transactions or data between businesses. Now, this type of electronic data interchange is used a lot in shipping, that is when we export and import items. Electronic data interchange is used to code the information about the data of import and export items, and this is a standard now used in shipping documents, so that at ports and airports it is very easy to process the data. Imaging and document interchange. The actual images of the forms and data are transmitted and received. Useful in applications in which the form images or graphics are required. Then another interface that we need to consider is the middleware. Now, you have heard of hardware, you have heard of software, you have heard of all this type of and software, again you say application software and system software and so on. Now, we will look at this type of ware called the middleware. This is the type of utility software that enables communication between different processes in a system. May be built into the respective operating system or added through purchased middleware products. You can refer to page 500 for more information. The process architectures, the software development environment, that is how the process architecture is dealt with. SDE is a language and toolkit for developing applications. One way to classify SDEs is according to the type of client server or network computing architectures they support. So, there are SDEs or software development environments for centralized computing and distributed presentation. Then there are SDEs for two-tier client server. There are SDEs for multi-tier client server. There are SDEs for internet and intranet client servers. Again, you can refer the textbook for more information. So, this is we come to the end of this unit, that is the lesson 6 in the syllabus.